So let's go over number 15 on page 781. They ask, what are the factors that affect the solubility of a salt in water? Well, what they're really asking, is what is affecting KSP, okay? So the only thing that's going to affect KSP is temperature, okay? So for almost all salts, if you increase the temperature, you are going to increase the KSP, okay? That's the only thing that's going to affect the solubility or change the equilibrium constant. Other people might say that, oh, if you add more volume of water, you're increasing the solubility. Well, you're increasing the amount that dissolves, but you're really not changing the KSP at all, the solubility. Similarly, you can change the pH. You could add a common ion, but again, none of those actually changes the KSP. Okay. Number 23. We're going to calculate the KSP for nickel hydroxide. We got 0.14 grams that dissolves per liter of water. So we got 0.14 grams of nickel hydroxide. So we're going to have to calculate the molarity of this. I don't know if you remember, but this is where sometimes normality would come in handy. Well, anyhow, let's calculate the moles. So nickel weighs 58.7, and 2 hydroxides, that's 92.7 grams, gives me 1 mole of the nickel hydroxide. Okay, so we'll calculate, and we're going to get 0.00151 moles. In this unit, you're going to get really small numbers, so don't be afraid. They're nice, they gave it to us in 1 liter, so my molarity okay. So the equation for dissolving is a very small amount of nickel is going to dissolve, and a very small amount of hydroxide is going to dissolve. Okay, so they told us how much dissolves. So the amount of nickel that dissolves is 0.00151 moles.
Sorry, I didn't catch that. You can also try spelling it.
The amount of hydroxide will be twice as much because of the mole ratio of 2. So those are the moles of each of those, each in 1 liter. So my molarity is 0.00151 molar, and the molarity of this is 0.00302 molar. Okay? The equilibrium expression is the products over the reactants. Well, the reactant is a solid, so it's not included in the expression. So it's just going to be nickel over hydroxide, but remember we raise it to that power. Okay? So then we just plug in the numbers. And my KSP is 1.38 times 10 to the negative 8. Okay, so that's how you calculate the KSP. Okay, and number 25 is a similar problem. Here they give us the concentration. It says that this solution is saturated at 2.14 times 10 to the negative second molar, which means that I would have 2.14 times 10 to the negative second molar of the lead ions, and I would have twice as much of the bromide ions. So my KSP is going to be my lead ions, my bromide ions squared, and then my KSP will be and I get 3.92 times 10 to the negative fifth KSP.